I'm Rajat. I'm a dev lead on the Windows SE team, and today I'll be talking a little about life as a WinSE developer. What are things we do in the dev team? So before we start, can I have a show of hands as to, I want to get a sense of what kind of audience this is. Are we all vendors here? Okay. Okay, one FT there. All right. And have you guys already had talks or discussions, or have you heard presentations about WinSE in the past? Or is this your first day where? Okay. So since the first day, we'll start with the very basics. All right. And so did Dennis talk to you about the business model? Yeah. All right. So this talk is going to be focused on WinSE development. And so this is the agenda for the talk today. I'll start by talking about the philosophy of being a developer in WinSE. Then we talk about the org structure, who's who in WinSE dev, what does WinSE dev look like. Then we'll go through a bug's life. The primary deliverable in our team is a hotfix, a bug. So we're going to walk through a bug's life and see the various cycles. Then we talk about our view of the world. So being a WinSE developer, what does the world look like? And then we talk about other deliverables that we have beyond bug fixes. Then we talk a little about the different projects and initiatives we do within our team. And finally, looking forward, what are the new things we'll be doing? So that's the agenda for the discussion. And if at any time anybody has any questions, feel free to stop me. We started 5 minutes late, so we might not be able to get to the whole presentation. But it'll be a 1 hour well spent if all your questions are answered. So anytime you have any question, just raise your hand and let me know. That clear? Okay. So let's talk a little about the philosophy of being a WinSE developer. Now, being a developer in the WinSE team is like being a detective. The reason I say this is, so I joined this team about 2 years ago. And I joined this team, and the first question I had was, hey, what do you guys do? Right? I came straight from school, so I really didn't have any work experience, so I asked them, what do you do? And the answers I got were stuff like, we're basically mechanics. Stuff like, we fix broken windows. So if Windows is broken, there's a problem with Windows. We are like mechanics. We investigate, find the problem, and fix the car or fix the automobile. And this idea, though it captures what we do, it really did not make good sense to me as a person who's fresh out from school and wanted to join Microsoft and change the world. Like, I'm a mechanic. That doesn't make much sense. So the way I view my philosophy of being a developer in a WinSE team is like being a detective. Now it's a little more cooler than saying that I'm a mechanic, right? So what I'm going to do is I'm going to draw a parallel between what a detective does and what we do. So it's a good way of trying to understand what we do on a day-to-day basis in WinSE. So like a detective gets a case to crack. The cases for us are bugs or issues in the Windows OS. So we work primarily on Windows operating system. And just to clarify, on NT4-based systems, we don't work on Windows 9X. We don't work on 98 SE, and Windows Millennium. We only work on NT-based platforms, like NT4, Windows 2000, XP, and Server. So the cases for us are bugs or issues in the Windows OS. The case details for us are the product sphere description and the CPR analysis. So like a detective, he gets a case, okay, there's a murder or there's some problem someplace, he goes to that place, and he looks around the room for case details, for clues. For us, those case details are the product studio description and the CPR analysis. So CPR is basically a group of people who raise issues to us. They're engineers who work in product support services. And just in case you're wondering, CPR stands for Critical Problem Resolution. So it's a group that does the preliminary investigation, and they hand off issues to us. So we get our case details from there. So like a detective goes snooping around and tries to work out the clues and get some answers, our investigation is basically debugging and analyzing the issue. So we use the debugger, we analyze it, we have a bunch of background information about the OS. That's how we go and investigate the issue. Then we locate the possible culprit, right? We try to find which is the part of the code that is breaking, that is causing the bug. And notice I say possible culprit. For example, the piece of code that we find that we think is causing the error may not be the real cause. So after we found the possible culprit, we need to verify our hypothesis. Like every detective, once he thinks that this person is a possible culprit, he has to get his hypothesis verified. And we do that through code reviews and testing. So we have developers in the Windows Core OS team that code review our fixes and tell us, okay, this looks good. And we also have our WinSE test team and the core test team. We leverage both these teams for verifying the hypothesis. Once that is done, we convict the culprit, we check the fix in, and solve the case by resolving the bug. So that's basically what we do. We're detectives, and we solve cases linked to the Windows OS. Questions? Yeah?
Yeah, which level of testing you were doing in your hypothesis?
Okay, so the question is, which level of testing are we doing in our hypothesis? So, firstly, the onus of the testing does not lie with WinSE dev, but lies with the WinSE test team. So we do some basic private testing or sanity testing. For example, if I think shell 32 or DLL needs to be fixed for a particular customer, so I'm going to create a private shell 32. All devs have test machines. We install that binary on the test machine, run some basic sanity tests, and then give it off to the tester. We also try to provide pointers to the test team that, hey, this is what I've changed, and it will be useful to test these particular areas. So we do a minimal set, but we provide pointers to the test team so that they can target their testing and not waste their cycles. Does that answer your question? Any other questions?
Related question. Do you use the same test scripts which is used by the test team, or do you have your own set of ways of testing your fixes?
Okay. So the question is, do we use the same test scripts as the test team, or do we have our own test scripts? The answer is, we don't use the test scripts owned by the test team, and we don't have our own test scripts. What we do is, every bug comes with a set of repro steps and business justification. And every developer who owns a particular component, he has a good idea of what he's changing and what could be the possible ramifications. So based on his own individual analysis, he'll do some kind of testing. But he'll lead the path or give pointers to the tester so that they can test other areas which he could not. So the idea here is that dev mostly spends its cycles doing bug fixes. So we try to limit the amount of testing we can do, and we leave the onus of the testing to the test team, but help them do their job. Any other questions? All right, so let's move on. Who's who? So this is the WinSE dev org structure. I'm sure Dennis must have talked to you about the overall structure of WinSE. So Mac, of course, is the general manager who reports to Brian V. This is the org structure. It's kind of small. Can you guys see this? Okay, so Alan Back, he is the dev manager. He reports to Mac, and Alan, he owns the entire dev org in WinSE. What we've done is we've divided the entire OS into 4 parts. Shell, printing, TS, app compat, that's one area, all the user fixes. Second is DS, security, group policy. Corey leads that team. The third team is base, setup, drivers, memory manager, that kind of stuff. Mark owns that team. And NK, he owns the team that deals with networking, FS, RAS, reader. So whenever a bug comes through, depending on which area it's based on, it goes through on these 4 buckets. And Mike Sliger, he works on patching, and he also reports to Alan. Apart from these 4 teams, I have my own team where I have 4 reports, where my team deals with critical situations in RFCs. I also drive long-term quality improvements, and I'm kind of a business manager for WinSE Dev. So one of my roles is talking about WinSE like I'm talking here right now. And basically evangelism, and I also own the IDC effort from WinSE Dev side. So that's my role. So this is how we've structured, this is how we managed to service the entire OS by having only 4 teams. So these are the 4 teams, they're based on functionality. So the individual devs in these teams, they have some kind of expertise about these areas. For example, somebody in Andrew's team would be an expert in printing. Somebody in Corey's team would be an expert in group policy. So that's the way we divide it. And the developers, they're generalists in a sense. So they have expertise in one area, the area which they own. Apart from that, they're generalists, and they can basically debug any issue in the OS. So that's the org structure. And any questions about that? All right. So let's start with the bugs life. Okay. Now in this section we'll talk about, so a bug or a hotfix is the primary deliverable for our team, and here I'll talk about how a bug originates, how it goes through the entire WinSE cycle, and how it finally gets released. And one thing I'd like you to keep in mind as you look at the next slide is that a number of different people are involved in a bug fix. There are different deliverables. There are different competencies of the people. There are different teams involved, and sometimes the issue can range through different continents. To give you an example, some bank in Australia has a problem, and they're going to report their problem to PSS in Australia, who are going to contact the CPR engine in Australia, who's going to contact the developer who lives in Redmond, and who's going to provide the fix to the build team. So a number of different people, different deliverables, different competencies, different teams and different continents may be involved. So I just want to keep this in mind as we go to the next slide. So there's kind of a lot of information on the next slide. So let's go through this. Let's read this clockwise, starting from the top, moving clockwise. Okay. So let's start at the customer and let's start moving clockwise. Okay. So I want you guys to follow me as I go through this slide. So I mentioned the customer with the $sign there. Okay. So he's the guy who reports the problem. So once the customer has a problem, he reports it, and someone in PSS at the phone, he's going to pick up the phone and say, "Hello, this is Microsoft. What can I do for you?" Right? That's the very first step. So this usually happens with customers who are like individual, like smaller companies or individuals. If it's a larger company, for example, say Boeing or Sony, there's one Microsoft employee who's associated with each one of these customers who's called a TAM. And his responsibility is to stay in touch with the customer. And if there is an issue which the customer's IT department cannot solve, he's the person who's going to help them solve it. So the first step is the customer reports the problem. Someone in the phone desk picks it up and says, "Hello, this is Microsoft." So this guy basically, he does a database search. He looks at all the databases, looks at all the existing solutions, and tries to find out if a solution already exists to the problem that the customer is reporting. If yes, he's going to solve the problem right there. If not, he has to escalate it. So he's going to escalate it to PSS, Product Support Services, and a bunch of people in PSS who are good at troubleshooting. So they're going to try and troubleshoot the problem. They're also going to try and look at a few more databases, try to find out if they can provide a solution. If they cannot, they're going to engage CPR, Critical Problem Resolution. Now, critical CPR folks, they are basically engineers. So they know how to reproduce a problem, they know how to look at source code, they know how to use a debugger. So they're going to engage the escalation engineers and try to solve the problem. If they can, they'll solve the problem. If they cannot, or if the problem requires a change in the Windows source code, they're going to escalate it to our team. So this is a little stack I've drawn here next to CPR. So what CPR does is once it sees, okay, there's a problem that requires a fix in the OS, it's going to assign it to AgDev. Are you guys familiar with Product Studio? Okay, so in Product Studio, there's a field that says assign to, right? Whom is the bug assigned to? So CPR, what they do is assign the bug to AgDev, and it goes to this big stack. Now all the dev leads, what they do on a daily basis, they look at this big stack and say, okay, which of the 4 buckets should this go into? Should this go into networking, DS, base, or should it go into user, right? So the dev leads, they look at this big stack, and they triage the bugs. And now from this, all the bugs in one stack, they divide it into 4 small sections, right? The sections I talked about here, the 4 leads. So they divide the bugs into 4 sections. And once the bugs are in these sections, then the individual developers, they look at the bugs that are present in their areas, and they assign the bugs to themselves. And they start working on it. Once they've worked on it, done the investigation, they release the private to the core team. They send it for code review to the core team and to the dev lead. Once the core team and the dev lead, they come back and says, yes, the fix looks good. They're going to release the private to CPR, test, and BVT simultaneously. So the CPR he is going to give the private to the customer, get it verified in the customer scenario, and then come back and say, okay, the private is approved. That's the point when the QFE dev is going to make the check-in, and someone in the build team is going to make sure that the fix gets built and release it. So this is the super simple, everything works, perfect world scenario, which it rarely goes through such a simple process, right? So at any stage, the process can break. For example, the CPR assigns the bug to act dev, and the dev leads look at it and say, this looks like a problem, but I don't think it deserves a hotfix. There's a workaround, or there's a tool that the customer can use to get around the problem. So he can reject the bug back and tell CPR, hey, I don't think this is a real bug. Here's the tool, here's the workaround, here's a registry key you can set, and your problem will be solved. So that could happen. Or an individual developer, he makes a fix, releases it to CPR. CPR comes back and says, okay, it fixes this problem, but it's created a new problem. So then the developer has to go back and investigate some more. So we went through the detective slide in the beginning, so you can basically mirror this to the detective slide and see that how it maps together, right? So the CPR gives us case details, we investigate it, then we find the possible culprit, then we get it code review to make sure the culprit is right, then we release the private. So this is the entire bug flow. There's some important dates I mentioned here. For example, for the WinSE dev team, we have turnaround goals. For example, for priority 1 bugs, we have to create a private within 7 days. For a priority 2 bug, 14 days, priority 3, 28 days. So the time we are goaled on is the time between the triage accept and the private date. So when the dev lead set the triage accept date to the time the developer releases a private, we have 7 days to do a prior 1 bug, 14 days for prior 2, and 28 for prior 3. Similarly, everybody on this map has goals for his or her turnaround times. For example, the build lab has to turn around in 48 hours or 2 working days. So the goals are on each one of these dates. And if you go to WinSE Web Dev, WinSE Web Back Dev, there are more details about this process. And I think I have it on the resources section also. So any questions about the bug lifecycle? Okay. So like I talked about, in this entire picture, there are different people involved, different deliverables, different competencies, different teams at different continents, right? So what is a single thread that links all these differences together? Yeah, I mean, it's obvious, it's huge, and big and yellow, right? So the customer binds all these differences together. So from the person who actually raised the bug, to the developer who made the fix, to the coder who reviewed it, to the builder who built it, everybody's thinking about the customer. And if there is one thing you want to take away from this discussion today, this 1-hour chat we're going to have, is that the customer ties all these people together. And no matter what your role is in WinSE, if you're a tester, or you're going to write some code, or you're in the build team, or whatever your role is, always have to think of what you're doing, how is it going to impact the customer. We are in this business because of the customer. Let's go back to the slide, right? It originates from the customer, it ends at the customer. And everybody here is thinking about the customer. So this one message I'm going to drill down to you guys is think customer, think customer, think customer at all times, right? No matter what you're doing, there's going to be some indirect or direct impact to the customer. Think about the customer at all times. And if there's a touchstone where you want to make, if you're not sure of a decision, should I do X or should I do Y, right? And there are many factors. Think of what benefits the customer most. Is it X or is it Y? And that will help you solve your dilemma. Okay? Okay, our view of the world. Now this slide has a lot of information on it. So, okay. So now here, let's start from the center. Okay, let's focus right in the middle. So this slide basically talks about how QFE Dev views the world. So, of course, everything is a part of Alan Back's org, and let's again start from 12 o'clock and move clockwise. Okay. So one of the teams we deal with is critical problem resolution, or CPR, like we talked about in the previous slide, and what is the interaction like? So with CPR, our interaction is we release privates to them, and they fill up RAID or product studio descriptions and file bugs, right? With the test team, we release privates for testing to the test team, and the test team, they run stress, sometimes they hit stress breaks, and we debug these stress breaks for them. That's our interaction with the test team. With the WinSE program managers, whenever we run into ambiguous issues or we're not sure what needs to be done, a business decision needs to be made, we loop in the program managers, and since they're aware of the processes and stuff, they can help us with that. And we also send bugs to them for war approval. Or if you know what's war, right? Okay, so I saw some like mixed nods, so I'll anyway tell you what's war. So war is a meeting that we have every day where we have representatives from dev, test, and PM, and you try to get traction and make decisions about issues that are present in WinSE. So the reason why it's named war is sometimes as you get close to a release cycle, for example, now we're trying to release TP12, the room is so chaotic, sometimes people get really angry and frenzied and excited, so sometimes it's like a real war room, but most of the time it's just another meeting. So that's war. With PSS they raise collaboration requests. We'll talk about this later in the presentation. Our interaction with the WinSE Build Lab is we submit package requests and build requests to WinSE Build Lab, and they help us build those. With the core developers, we send code review requests to the core developers, and they review that for us. All right. So that's the WinSE dev team, and I'll send you a link to this presentation. And most of these ovals, they actually are links. So if you can click on them, you'll get more details about, say, CPR or QFE dev and stuff like that. Okay. So any questions? Yes, please.
Do you directly release privates to the CPR and CPR sends it to the customer?
Yeah.
Is it supposed to be done in minutes?
Okay. So the question is, I think it's a little more related to this slide. So the question is, do we release privates directly to customers or not? Right. So the answer is yes. We release DLLs and EXEs and privates to customers. And what customers do is they we release it to CPR. CPR takes those privates and goes to the customer. So the customer has to get around Windows file protection to install these privates on their machine. So you cannot take a new shell 32 and go to system 32 and replace. Right? There's Windows file protection kicks in. So you'll have to go through either use the recovery console to replace these binaries. Right? So all binaries that are present in system 32, they're also present in DLL cache. So if you go, say, for Windows XP, you go into Windows System 32, there's a binary there. The same binary also exists under DLL cache. And there is a feature called Windows File Protection that prevents you from copying, changing these files or deleting them or replacing them. So what we tell them is, hey, you have to get around Windows File Protection. And you can get around that by using the recovery console or using like a multi-boot, stuff like that. So does that answer your question? So yes, we do release privates to them.
Does it mean that by the time the bug reaches QFE dev, the problem is already fixed because you have already verified with the customer whether your private has bugged or not?
That's correct. So yeah, okay. Oh, I see where you're going. Okay. So we release a private to the customer, okay, just to make sure that it works in a test environment. Does it work in the real scenario? But the release mechanism is not a private. So the thing about a private is difficult to install, right? You'll have to go around system file protection and stuff like that. So once the customer says it works, CPR comes and tells us it works. What we do is we get it built, and when it gets built as a package. So now you can just like click it once and it'll do all the good stuff and install on your system. So just before we verify that the fix works, we use a private binary. Once we know it works, we use a package. A package has a better user experience. For example, if a customer has 1,000 machines where he wants to install this hotfix, right? He cannot go. I mean, he can, but it would take a lot of time for him to go individually to go to each machine, get around system file protection, and copy this binary. Right? So we have the build lab build the official private, and all he has to do is go to the download site, click on the package, and it will install on his system. So that's the way it works. Any other question?
How long it is the time when the customer gets a taste of the private build and the actual thing is released? Because then he has to wait after he knows that the fix is done, but still it needs to come to me as a proper build.
Yeah. Okay. So the question is that how much time does it take for the customer when he approves the private and when he finally gets the package? Okay. I talked about this. It's the time between the private approved to the final fix posted, and the goal for us is once the customer tells us that the private is okay, the goal for us is we check it in 1 day, and the build lab has 48 hours to release the official package. So it's a 3-day turnaround time, unless something breaks and then it takes longer.
But the private private goes only after the test team has done their round of testing, right? It doesn't go before, or is it happens in parallel?
So the question is, does the private go out only after the testing has been done, or the testing is done in parallel? So this is a loaded question. In an ideal world, we like to get all the privates tested before we release it to customers, right? But since the turnaround times, the expectations are so high, like 7 days for a prior one issue, we try to get this done in parallel. But it's not a rule. A developer need not give a private to a tester before he gives it to a customer. But it's a policy decision. Some people do, some people don't. I personally do. All right. Any other questions? Okay. So continuing on our view of the world. So there's a lot of collaboration, chaos, and flux in our world. We have to collaborate with a number of other teams to make sure that things work for us. There's a lot of chaos. Things are always changing in the WinSE dev world. Anything can break, and basically there's a lot of change. Which brings us to the next section, beyond bug fixes, other deliverables. So till now I talked about the philosophy of our team, what does our team look like, and how do we work on hot fixes. Okay. So bug fixes, hot fixes, they are our primary deliverable. So in this section I want to talk about what are the other things we work on. So I won't go into great detail here. I'll just touch upon what does the term mean and what are the goals for our team. The first one is an RFC. RFC stands for Request for Collaboration. They're basically technical questions that get raised by PSS. So if product support is debugging an issue, gets a stack trace and really doesn't know what it means, or is unsure of what it means, or is trying to find a particular tool to solve a problem, or has a question about the design of the OS, this is a mechanism by which they can raise technical questions directly to the product group. One of the ways to do it is to use technical forums, right? RFCs is another medium to do that. The technical questions that get raised by PSS to help them debug the issues. And the goals around RFCs is to get product group assistance on difficult customer issues. So if PSS is debugging a bug check in Sony, one of Sony's machines, and cannot get anywhere, so he can ask a question to product group via an RFC, and we can help him get traction on that issue. So that's what RFC is. Critical situations, this is of course one of the things that I own, my team owns. Critical situations, they are emergency or catastrophic customer scenarios that require urgent attention. For example, we talked about this bug flow, right? And as you can see, this has to go through a number of steps. And each team has like a 1 week, 2 week, 2 days, some kind of a turnaround goal. And if you add all those values up, for the customer, the end-to-end experience could be like 1 month or 1.5 months. Or if something goes wrong, could be even longer, right? And if we have an emergency situation, for example, Monday morning, all machines in Boeing start bug checking, right? They cannot get any work done. They cannot wait for 1 month before they get a resolution to that problem. This is a catastrophic situation and it requires urgent attention. Or there's a company of 1,000 people and Monday morning no one can log in, right? It is a problem that requires urgent attention. So we've created a different escalation path for these kind of issues. And these kind of issues are called critical situations or CRITSITs, right? In case you're wondering why there are so many abbreviations in WinSE, we love abbreviations. We just love them. And wherever possible, we create abbreviations and short forms for stuff like CRITSITs, RFCs, stuff like that. So the goal here is to provide consistent, predictable, and swift handling of critical situations. Okay. So these issues are very important for the customer. They're causing a lot of financial damage to the customer and requires urgent attention. So here we have like a 2 to 3 hour turnaround time. For example, if PSS cannot do it in 2 hours or 3 hours, they have to escalate it to the next level. If CPR cannot solve the issue in 2 or 3 hours, it has to get escalated to product group. And actually, in a space of like 14 to 15 hours, you have the vice president on the email thread. These are so important. So we need to get real urgent attention. So that's basically CRITSITs, and the goal is to provide consistent, predictable, and swift handling of these issues. Stress breaks. Now, stress breaks, like I said, the test team, they run stress, and whenever the machine, there's a problem, the machine breaks in the debugger, and the dev team looks at these breaks and tries to solve these issues. A GDR is a general distribution release. It's basically a hotfix that gets posted on the web via Woo, and then a lot of people who download it. The goal here is to release crucial fixes to Windows customers in a systematic and customer-friendly way. I'm sure you guys have heard of these terms, right? GDR, stress breaks, and okay. The next deliverable we work on is a service pack. Okay. I'm going to not explain what a service pack is, because if you guys are working in the Windows SE team, you should know what. Or I'm sure all of you know what a service pack is, right? Okay. A service pack is basically an accumulation of hotfixes and GDRs, and we have a periodic release. We release them like every year, and it goes through a lot of testing. And if you want to look at more deliverables that our team owns, this is a website here. You can check this out. This also has other WinSE dev lingo. We have the words we use and other terms. So that's beyond bug fixes. Okay. So let's talk about the other projects and initiatives that WinSE dev is working on. So one of the major issues we deal with are binary dependencies. Okay. So I want to spend 2-3 minutes trying to explain this concept. So let's not read that now. Let's try to understand it, and then we'll get to the definition. So say you're a developer in the WinSE dev team, and you're making a fix. Suppose the fix requires changes in 2 binaries. Okay, let's call them a.dll and b.dll. All right, and say the fix is in b.dll is some function foo, which had 3 parameters. Now you want to make it have now it needs 4 parameters. So you create this new parameter. All right, and you code this function up. Now a.dll calls function foo, which is present in b.dll, right? So now in all places in a.dll where you call function foo, you got to change the function from 3 parameters to 4 parameters. That's right. Okay. So what this means is, so all of you are with me, right, with the fix. So this b.dll contains a function foo. It had 3 parameters. Now I've changed it to having 4 parameters, and I've coded this function. In a.dll, I'm calling this function foo, and in all places, I'm going to change it from 3 parameters to 4 parameters. Okay. Now, basically what it means. So what's going to happen if I ship the new version of a.dll and the old version of b.dll? Anybody? Well, what's going to happen? So in a.dll, I'm calling foo with 4 parameters, and so on a customer's machine, if I only install a, I have a.dll calling foo with 4 parameters, but my b.dll only accepts 3 parameters. So what's going to happen? Yeah, it's going to be unpredictable behavior. Most probably you're going to crash, right? So what does it mean? It means whenever you ship a.dll, you have to ship the new version of b.dll, right? Because if you don't ship the new version of b.dll, your system's going to crash, or you have a function call that's not defined, right? Can you ship the new version of b.dll with the old version of a.dll? So a.dll depends on b.dll now. So a.dll cannot ship without the new version of b.dll. Can you ship the new version of b.dll without shipping a.dll? Well, the answer is you can, because so b.dll now has 4 parameters, but nobody's calling into them. So this is basically what it means is you created a dependency between a.dll and b.dll, and you cannot ship the new a without shipping the new b. So I'll go through the definition. There are lots of details. This is a whole topic in itself. So it's called a binary dependency. A binary dependency occurs when a change is made in 2 or more binaries, such that new functionality in one binary requires changes made to other binaries, and the change was made in such a way that existing functionality would be broken if one of the changed binaries was a previous version. It's really contorted. What it basically means, you cannot ship this one binary without shipping the other one. If you do that, existing functionality will be broken, right? So if you had coded, so let's go back to the example I talked about. So in a.dll, if you could have somehow coded it in such a way so that existing functionality will not break, you don't create a dependency. Dependency only gets created if you break existing functionality, right? So that's a binary dependency. And the reason you track them is more interesting. So see now say a.dll depends on b.dll, okay? That means whenever you ship a hotfix containing a, you got to ship a hotfix containing b, okay? Suppose b.dll also depended on c and d.dll, right? So now it means whenever you ship b, you got to ship c and d. That means with A, now you got to ship B, C, and D, right? Suppose D depended on like few more, and C depended on few more, which depended on some more. Basically, now it means when you ship A, you got to ship all these zillion binaries with A.dll, right? And there are a lot of problems here. The test hit becomes huge. With every change, you got to test all these binaries. The size of the package increases. The download size is high. So somebody with a modem will take him forever to download these hotfixes. So this is a really big problem because of the chaining effect of dependencies, right? So dependencies must be avoided. So dependencies can be one-way, two-way. The one I described is like a one-way dependency. You can also have two-way dependencies. Dependencies get created in these ways. I won't go into great detail. I'm going to leave some time for questions in the end, if you have any questions. So if you want to learn more about dependencies, you can go to this website. It has some links about whom you can ask follow-up questions to. So you can look at that if you're interested in dependencies. It's a very interesting topic, and we have been trying to tackle this. Okay. Other things we work on, we do internships too. We do CPR and WinSE test internships. What is it? It's a customizable and structured 2-week training module for CPR engineers and test engineers, right? So basically, we try to help test engineers improve their debugging skills, learn about WinSE dev processes. So they come to the WinSE dev team for like 2 weeks to learn more about WinSE. Also, CPR engineers all over the world, they come to WinSE for a 2-week internship to learn more about debugging and WinSE processes. So again, the details are at this site. I won't elaborate more on this. Okay. Oh, this is interesting for you folks. So one of the things we work on is the WinSE Dev Talk series. So on a month or a monthly or a bi-monthly basis, either a developer in the WinSE Dev team or someone in the core team, he makes a 1 hour to 2 hour presentation about some area of the OS with a focus on debugging. So say one of you owns the testing for RAS or say RPC, right? So you could go to this website. The developer on our team who owns RPC, he's made like a 1.5 hour to 2 hour presentation about RPC with a focus on debugging. So if you're new to RPC, you want to learn more about it, or you already know stuff about it and you want to refresh your memory, you can go to this page. There are talks on different areas of the OS, like from shell, networking, RPC, like 14 different topics are there. So these are regular lectures on NT components that focus on architecture and effective debugging techniques. So you can go to the site and you can view you have the presentation slide, you have the PowerPoint slides and also a video. So you can look at the video too. So any questions so far about? Okay. A couple of more things I won't go into detail. I think you'll have presentations and talks during this series about the Windows Diagnostic Portal and tracing, so I won't go into this in more detail. And also, you can find more information about these two on those websites. All right. So, okay. So, any questions about the other projects or initiatives we work on, like dependencies or talks, internships? All right. Okay, so looking forward. So what are the new things, new initiatives and new projects that WinSE Dev has started so that we could improve the sustainability experience for the customer? One of the things we started is engineering reviews. Again, I'll be brief about what it is and what are the goals. An engineering review is basically a collaborative effort between the dev team and the core team to make sure that the packages we release in GDRs through WU, they are of high quality. Basically, developers, testers, and PMs, entire engineering orgs, we sit together in a room and pull up code changes and look at the code changes and try to ensure that the fixes are of good quality, they don't regress behavior, stuff like that. So that's basically an engineering review. And the goal of the engineering review, or ER for short, is to come up with recommendations on what additional work needs to be done to improve robustness. So we release these GDRs on Windows Update, and in a matter of weeks or days, millions of people around the world install these GDRs, like security fixes and stuff like that. So we got to make sure that the quality of these releases on Windows Update is extremely high. So apart from going through code reviews, testing, stuff like that, we got to make sure we conduct this extra step called engineering reviews to make sure that there are no problems. And this is a very time-intensive effort, but we found a number of issues doing engineering reviews. So that's an engineering review. Risk assessment. Okay. This is another tool that we're working on. Think of it like if you were in Vegas, and if you were in Vegas and you were playing WinSE Dev roulette. Okay, you're playing roulette on WinSE Dev hotfixes. You want to put some money on WinSE Dev hotfix and say, okay, I'm going to put $100 that this hotfix does not regress any behavior, or this hotfix is good. The confidence of this hotfix is 2 out of 100. So if you get a really low number, the developer's like, geez, maybe I cannot release this on Windows Update. So he's going to go and do some more code reviews or do some more scrutiny and try to make sure that the risk assessment value is higher, right? So the idea here is once we have a value of confidence for each hotfix, we can prioritize our efforts and test the ones which have lower confidence. For example, and this is going to be based on a number of factors like history, complexity of fix, etc. We have had some binaries in the past which are more regression prone. So if you're making a 1,000-line change to one of those binaries, the risk value is going to be really low. So the risk value is going to be really high, the confidence is going to be really low. So you can improve the confidence by extra testing. So the idea is to come up with a quantitative value for the degree of confidence. And we're trying to develop some confidence indicator tools, but this is still in the prototype phase, so there's a long way to go here. The goal here is to understand, so now we don't know which hotfix is better than the other. So the idea is to understand hotfix risks. The idea is to understand, calculate, track, and communicate hotfix risks. So if we have a problem with any hotfix, this is a way in which we can objectively capture what are the risks involved or how much confidence do we have. So, any questions about engineering reviews or risk assessments? All right, so I think we have 10 minutes more to go, and I'm mostly done with my slides. So we can spend some time if you guys have any questions or if you have any comments.
Can you request for some talk sessions?
I'm sorry, but
Can you request for certain tech series sessions you had, right?
yeah, like what do you have in mind?
If there is something which is not covered or areas where we might need more information on specifically.
Okay. Okay. So the question is, can we request for extra talk sessions? The answer is yes. And you can send mail either to me or send mail to Andrew GR. He owns the talk series, and we can make sure to do that. And I have one question for Kaushik. Does the sound work here? It does. So, yeah. I think I'm mostly done. So how many of you have seen the movie The Matrix? Which one? The first one. Well, how many of you seen it? Okay, okay. So I'll get to that in a minute. And we're also going to do engineering reviews on a triggered basis for hotfixes. So let's see if this works. A really nice sound clip here. Guess it doesn't work, but the idea is, I really like this movie a lot. And the idea here is, if you're working in WinSE, just think of two things. Think about the customer. Okay, I think I've emphasized that enough. Whatever you do, think how you can improve the customer experience and free your mind, right? If you have any questions, feel free to raise it. Go to the dev team, go to the test team, ask any questions, send email to the right forum, okay? And I'm not sure if I have a section about resources here. No, but I'll follow up. I'll send a mail to Kosh about the resources that you can look at, all the stuff I talked about, the WinSE dev site, and you can go to that site and get follow-up information. You'll have email addresses for people who have information about stuff you might be interested in. So feel free to send them email. So basically that's it, unless you guys have any questions. No questions? All right, thank you.